Welcome to this week's Mind Technical Talk. And today we will be talking about Open Source Summit Europe and Linux Plumbers Conference, two conferences that were in Vienna mid-September. The original plan was also to include Kernel Recipes, which is another conference that was the week after in Paris. However, the session was already pretty full, so we decided to delay that one for another Mind Tech Talk, and that will in fact be the 20, I forgot the exact date, end November will be the talk about Kernel Recipes. A second message is that so in this talk, I'm going to go over different sessions, different talks that were presented at these conferences that are somewhat interesting. And the idea is to give you the opportunity to look at either the slides or the full video on your own when you think that indeed it is interesting. So it's kind of first level filtering. You're not going to learn too much by just listening to me here, because it's very limited, the amount of time I can dedicate to each talk. But so the idea is to look at the full talks. And there's also an option to do this looking at a full talk as a Mind Tech Talk. That will give us also the opportunity to discuss the subject of that talk. So it's mostly useful for not super technical talks, or where there can be other ideas or something like that. So as part of this session, I also have a poll to gauge the interest of people to have one of these subjects as a full tech talk, or it can be more. It's maybe even possible to squeeze two presentations in a single tech talk. But so we'll see that later. So Open Source Summit Europe and Linux Plumbers Conference. Let's start with Open Source Summit Europe. So that was from 16 to 18 September in Vienna, in Austria. And Open Source Summit, it's a collection of a number of conferences, a quite large number of conferences. Some of these have originally been separate conferences and then gathered together in the umbrella of Open Source Summit. And some of these conferences have started immediately as an Open Source Summit conference. So it used to be a long time ago just LinuxCon and Embedded Linux Conference. So these two, that was in 2010 or 11 in Barcelona, the first time that those two were together. And so this has grown quite a lot, as you can see, maybe a bit too much. So now it's really a huge conference with a lot of different tracks. Unfortunately for us as embedded software people, there's not that much which is interesting. So the interesting ones I've indicated in bold here. So is the Critical Software Summit, the Embedded Linux Conference, LinuxCon and Zephyr. And in LinuxCon, it's general about Linux, so often it's still about server use cases, and so not that relevant for us as embedded systems developers. But of course, we also do non-embedded system stuff, so yeah, that can still be interesting. But so the talks that I'm going to discuss here mostly come from these sessions, from these conferences in bold. And so now let's dive straight into the first talk. So this is going to be at a crazy pace, a 45-minute talk summarized in 2 minutes. So hang on. And so you will also see on the slides, always see on the slides, the title of the talk and the authors, and then a link to the details of that talk. And then in that link, you can also get access to the slides of the talk itself and to the video recording of the talk. And sometimes there are additional links to more information, like if it's about some specific project, a link to that project. So the first talk I want to discuss, the first couple of talks are more technical talks, so about a very specific technical subject. So the first one is a Zephyr talk. In beginning of this year, in April, I think I forgot the release number, but there was a release of Zephyr in April that has introduced 2 new features in the build system, which are quite dramatic, invasive. So the first is called sysbuild, and is basically a way to build multiple images in a single build. And so this talk describes how that sysbuild system works. The main takeaway is that they've decided to keep it separate. So there is a separate menu config for configuring a single board, and then or a single image, and then the sysbuild menu config to configure how these different images are created. So in this configuration, for instance, there is a bootloader which is built separately and gives a separate image, and then one sub-project that is included there. So it's actually a super trivial sysbuild. But so this is meant for boards that have either multiple MCUs or an MCU that has multiple cores and where each core runs separate firmware. But it can also be used for something simple like building the bootloader separately. So yeah, go into details if you want to know more. Then the same talk also talked about the new hardware model that was introduced in the same Zephyr release. Basically, before that release, the way that boards were organized, so everything is based on a board target, and the way that it is organized is, on the one hand, first of all, it was organized per CPU architecture. So you have board/ARM and then all ARM-based chips. But that becomes a bit weird if you have a board that has multiple chips with a different architecture, like an ARM and a RISC-V chip, or again, a multi-core system on chip that has multiple architectures, which does happen actually, that you have a multi-core system with a RISC-V and an ARM chip. Core, I mean. And so that's why they introduced this new hardware model. And the second thing that this new hardware model did was make the formalize the way that you specify different variants of a board. So what you have is you have the basic board name, which is organized per board vendor now instead of per architecture. So you have, for instance, board/Nordic, where Nordic contains the Nordic development boards. So there's a basic board name, and then that corresponds to a directory like board/Nordic/BL5340_DVK. And then within that board directory, there are different variants or different variants defined. So how are they defined? What are the components that can be used to define them? First, there's a board revision. So if you have several revisions of the same board, you usually have like a shared device tree includes, and then a DTS file for each different variant. And so they've made the way that the board revision is specified in that case, formalized it. And then if you have a board that contains multiple systems on chip, then that comes with a slash afterwards. And then if that system on chip contains multiple CPUs, then you have the CPU afterwards. And then finally, if you then have different variants of the configuration, like different hardware enablements, then that's the last bit. And so the total thing is the board target, so that is what you give on the WIST command line. About this talk, I've talked way longer than I should normally talk about every separate presentation. I'll try to do better. Also, because all these presentations are kind of separate, I'm not going to do questions at the end. I'm going to ask if there are questions or remarks or anything right now. So do you have any questions or remarks about the Zephyr new hardware model in sysbuild? I see no reactions. So we move on to the next talk. This one, it's an interesting talk because it contains quite a few suggestions, but the talk itself was actually not so interesting. So it's more something to look at the slides. So this was a talk about what you need to do or how you can approach when you have a problem with the memory usage in your in an application. So it went over things like detecting memory leaks, to finding out which process is or which executable is taking most memory, over things like, okay, what can you do about the memory, also kernel memory usage, and so on. So it's a very comprehensive talk, but I think more useful as a reference than as really watching the video. I'm give one example here of what was discussed in the talk. Is the SMEM tool, which is not installed by default on most systems, and it's actually a Python tool, but it also has a capture C tool that you can install on your embedded system and then offline do the analysis. And so it has a bunch of graphical outputs, but also these textual outputs. And basically, the important thing that it does is it splits the memory usage into. So normally you have RSS, the resonant stack size. That's what you get in top, for instance. Unfortunately, it's not a very useful measure because so if you have pages which are shared between different processes, then all of these processes, only one of those processes will have it accounted for in its RSS. But that makes it difficult to compare the different processes. So what this tool does is it says what it calls RSS is all the memory used by that process, even if it's shared. So that's why the total of RSS is bigger. And on the other hand, you have the USS is the unique set size, and the PSS is a proportional set size. The USS is the part which is not shared at all, and the PSS is the part which is shared and which is then divided by the number of processes that use the same page. So the total of these two is the actual amount of memory used, which is lower than what it looks like in the total of resonant set size. So yeah, this is an interesting tool, and a bunch of other interesting tools, many of which you probably know about, are mentioned in the talk. Any questions or remarks about this talk? Yeah, Olivier? No, Olivier. Okay, sorry. I saw Olivier going, unmuting himself, but...
Okay, do you hear me?
Yeah. Yes, Olivier?
Just mentioning that we have had a very similar talk, but possibly going further for memory analysis in Kernel Recipes. So that will also be presented next month. That's it.
Yeah. Thank you. All right, next talk is about Linux power management features. This is a talk I didn't attend myself, and I'm checking if the person who was there, I think it was Thomas, but Thomas isn't here, right? No, I don't. No, Thomas is here. I think, Thomas, you attended this talk, right?
Oh, yes.
Okay, so I will introduce it, but feel free to jump in to say more. So basically, this talk is about, basically, it's like the previous talk. It's has a very wide scope. It goes over a lot of different things related to power management in Linux. So it goes over what this is about is suspend and hibernate. So suspend is basically going to standby, or well, it's actually suspend to RAM. Hibernate is basically shutting down, but being able to start up again without going through the normal boot process, but just recovering the memory image. And then you have, in addition to suspend to RAM, you have less aggressive ways of suspending as well. So that was one part of the talk. Another part of the talk was runtime power management of devices, which basically means that when a device is idle, so like an USB flash drive, when it's idle, it can be turned off to save power. And what were other things? There was a third power management feature that was discussed as well. And so these features were discussed both in how they are used from user space and how they are implemented in the kernel. So which kernel hooks you have to implement in a driver to support it. That's about it. Thomas, anything to add?
No, it was a good quality talk. Like, yeah, really wanted me to recheck again to learn a bit more about the reference they use. So definitely something to check out.
For me, it was not really anything new because I knew it already, but it's a good introduction to know what exists in drivers to do this suspend and resume, and yeah, how it makes a driver more complicated to be able to do that. Any questions or remarks? Oh, Olivia?
Yeah. Yes. There is one more goal that you may have there aside of power saving when you write low latency, that is booting faster. And I think Hibernate could help there. And I've seen few Linux embedded systems that are actually using it. It looks complicated to wake up our hardware and pick up the work where it was, especially for GPUs and things like that. But it's a very interesting subject.
That was not actually discussed in this particular talk, but it's true that you may think that the suspend to RAM and Hibernate are not relevant for embedded systems, but indeed it's something that you can use to fake booting faster. You're not actually booting; you're just resuming from Hibernate. Yeah. Anything else? All right, moving on to the next one. I guess most people have heard about the year 2038 problem. So it's a kind of similar thing to the year 2000 issue, that there is a rollover, and in this case, it is the 32-bit signed integers that are used in the time T type in C or in Unix. We reach the rollover, or the maximum signed integer, counting from January 1st, 1970. We reached that on the 19th of January in 2038. So at that point, any 32-bit time T will overflow. It's actually a problem that at first sight is pretty much solved, in the sense that Muscle supports 64-bit time T, glibc supports it a bit more recently, and then it only exists on 32-bit platforms anyway, because all 64-bit platforms have 64-bit time T. So this talk goes a bit about a study about the different places where he looked at to check that things are okay. And in the Yocto context, because Alex is one of the main Yocto maintainers, or Open Embedded, I should say. So this slide slides I picked out of it, I thought was the most interesting one, because so although in glibc and in the kernel, these things are pretty much fixed, so you just need to use a recent enough kernel in glibc, and then for glibc you also have to add a define, which is annoying. However, it turns out that there are many applications that accidentally write the time t to a 32-bit long or int, which basically means that even if time t is 64 bits, you still have the problem, or potentially have the problem. And so he, in this study and testing, he found quite a few cases of open source tools that have such instances of converting a time t to an int or a long, which is depressing because it means that, yeah, it's not so easy to solve the problem. I also didn't attend this talk myself. I think it was again Thomas that attended this one. Anything to add? Yes, OpenSSL, indeed, Olivier. All right. Any questions or remarks other than, oh my God, OpenSSL? Yes, Charles-Antoine?
Yeah, I know that, as you mentioned, glibc should be compiled with a specific define to enable this feature, I would say. I know that they are working on Yocto to provide it by more or less by default. What is the status on Buildroot for this?
In Buildroot, there's an option to pass this define, basically.
Okay.
So you can say I want 64-bit time, and then this option is passed. And that's actually for Buildroot is an transition measure. The idea is to remove that option and always do it in the future. In Yocto, I think, as far as I know, it was already done in the ScartGarp release.
Yeah, maybe the latest one provided.
No.
I've not checked yet.
Because well, this all the things that Alex discussed are definitely in upstream Yocto. Anything else? Moving on. This one also I didn't attend, but I was sorry about it because I looked at this. I didn't look at the video yet, but I looked at the slides and it looked really interesting. So the slides were a little bit confusing, but the message was very clear. Basically, you have in Linux two separate subsystems, pin control and GPIO. But they are, if you look at the hardware, they're pretty related. First of all, sometimes it's even implemented in the hardware in a single device. So there's a single register set that controls both the pin control and the GPIO. For people who are not aware, basically GPIO is being able to write a 0 or 1 as output or reading 0 or 1 as an input on a specific pin. And pin control is saying how a pin is multiplexed and if there's a pull up or pull down, and if it's sometimes configuring a drive strength and things like that. So it's configuring a specific pin. So they're separate in Linux, mostly for historical reasons, because GPIO already existed for a long time. Pin control was board specific or SOC specific for a long time without common driver. So when they introduced a subsystem for it, yeah, it was not easy to reuse GPIO for that. And so that's why they're different subsystems. Now, the problem is that they're basically separate drivers and separate device nodes for the pin control and the GPIO, separate places in the device tree. But they are not that independent. So the most obvious one is that you have to multiplex the GPIO, the pin as GPIO to be able to use it as GPIO. And this is normally done automatically. So that means if in user space you enable a certain GPIO, that this multiplexing is automatically done. But that means if there is another driver actually using that pin, that that other driver suddenly stops working, and it's not made aware of that. So there's this point. And another thing is that in hardware, again, they are often not that independent, in the sense that, for example, when you configure a GPIO as output, it is actually implicitly done by putting a pull up or a pull down on it. So it actually has to, well, it actually affects the pin configuration, but the pin control driver doesn't see it. And so this kind of conflicts, usually you don't really see that effect, because the GPIO is only used for one purpose anyway. But the effect where you see it mostly is that in some cases you have something, for instance, output enable on the pin control. But the way that the pin control driver is implemented, it actually doesn't do anything unless that pin is also configured as a GPIO. And this output enable is done on something which is not a GPIO. So if it's a pin that is used by I2C, but actually you have to configure it as GPIO to actually be able to use it. So this kind of weirdness you can have in the device tree. And so the guy has two pieces of advice. First one is there is a strict mode that basically avoids this override thing, so that there is no implicit pin control request when GPIO does something. At least that's how I understood that this strict mode works. And then a second advice is that the pin control drivers should be reviewed to see if they are really doing the right thing. Well, it gives a number of foot guns where the driver could be something wrong. So I didn't attend the talk myself. I'm not sure who was the one. I don't think it was Thomas this time.
Yeah, me and Radwan.
Okay. So anything to add, Thomas or Radwan?
No.
Any questions from anybody or remarks? Another one that I didn't attend myself. Basically, it's a talk about how to debug crashes in Yocto using tools that are using various tools. So it's very technical. It's, again, to me, looked more like a reference and not so much like an informational talk or a discussion. There's not much more I can say about this. Radwan or Thomas, anything to add? Or any questions or remarks? Moving on, this one was specifically for me interesting because it was people from Zeiss Electronics who are working on a medical microscope. And I'm also working on a medical device, so it came close to home. So where this talk comes from is basically in medical devices, you have to follow regulations, and these regulations basically require you to follow the V model. So you have analysis and design phases. You go down to an implementation, and then you have to test that implementation at the levels that it was originally specified. At the left-hand side, you do specification, and at the right-hand side, you do verification. There are different terms, but they don't really matter now. And so you have to make this link. So you have these horizontal arrows. You have to test what you specified, basically, which is a lot of manual work, and it's hard to maintain consistency between what you test and what you specified. And so they went to look for a way to do that more smoothly. And the first thing they stumbled on is Fritz, which is a tool to write requirements down in a more formal way. So it's not strictly formal, but it's somewhat formal in the sense that every requirement has to be written as a sentence which contains these components, where the component, the shell, and the response are obligatory. So all sentences look like, all requirements look like in one of these modes. Upon an illuminate on request, the illumination controller, so this specific component, shall within 200 milliseconds satisfy and then a condition. So the second part of the formality is that you have these formulas in here, like sample prep or capture, and here an and equal, and so on. And also that you have timing, which is specified in physical units. So yeah, that's a nice tool to specify requirements. And what they have added to that is to automatically generate tests from that, or not fully automatically. You still have to do quite some test implementation work, but because the test corresponds to the requirement, you want to automatically have this matching. That is the basic idea. And so to make those tests, they basically use the robot framework, which is a kind of a translator from human language. Basically, in the robot framework, a sentence like this, like the illumination controller, is translated to some Python code. That's a very high-level view of what the robot framework does. And so they use that to generate tests in Python. And then they also integrated that with the Twister framework, which is a test framework used by Zephyr. For people who have used Gherkin as a language or Cucumber as a test generation tool, this will look familiar, because it's basically the same principle that you write pseudo-natural language test specifications in the case of Cucumber, and that they can be automatically converted into test codes. Questions or remarks about this? Moving on. Another talk I didn't attend myself. Richard Weinberger is a guy who is a security expert. He's been working in security on Linux for years. Mostly in advising others how to improve their security. And so this is a kind of a summary talk about his knowledge, you could say, specifically for embedded systems. I'm not sure what the Dr. Jekyll and Mr. Hyde. Yeah, it's the good and the bad, but I didn't really see it in the talk, but okay. The main takeaway is that there are many features in Linux to make it more, I say secure here between quotes, because you really have to define a threat model and so on, and risks. So you can't say that something is secure. So there are many features that help with making a system more secure, but you have to make sure that they're enabled. So often you have to consciously enable them. They don't come automatically. And also you have to be sure that you don't disable them by accident. For instance, there is this rel-row option that you compile. When you at compile time, you say that whenever a dynamic library is loaded, that its executable section becomes read-only, that you can't overwrite it, which is a defense in depth against takeover of that executable. But it's easy to accidentally add a compiler flag that disables that rel-row again. So that's the kind of thing you have to be careful with. But yeah, there's nothing really. There are a few tools that check whether malware was indeed applied to an executable. But other than that, yeah, you have to just be aware of the problem. And the second thing point he made was about CVEs and vulnerabilities in software, where basically there's no other option than following upstream and so doing updates. But that is hard. But there's really no second way about it. Questions or remarks about this one? So now we come, as you have noticed, in the less technical and more, well, it's still technical, but more taking into account requirements and security and so on. So not just coding. So this is about license obligations. Basically, with the open source licenses, they come with a number of obligations. So it's not a free for all. There are certain things you have to do, and you can split these in 4 types of obligations. There is information obligation, which is basically saying that this is the author and this is the license. You have to give that information to your downstreams. And then there's disclosure obligations that you need to give the source code in cases where this is needed. And then there are licensing obligations. That is what you can, the limits that you have in how you can license software that or other software that uses that particular software. So this is mostly about the LGPL type of limitations. But even like MIT says that sub-licensing is possible, but yeah, there's still a limitation to that. And then there can be additional obligations. I don't have a concrete example in my head. And so the main message that he gave was, so distro generators, meaning Yocto, Buildroot. He also looked at some less popular ones. They can help you conform to these obligations. However, not really for the licensing obligations and the additional obligations, because those are less formal. Those are so the licensing is kind of what license are you allowed to give to your downstream. So the tool can't really help with that. But also it's not super complete. You also have to do some additional effort, even for the information and disclosure obligations. Questions or remarks about this one?
Yes, there was already a talk about it in embedded in Nuremberg in April.
Yeah.
It's an interesting, the job of OS ADL looks interesting on that side.
I didn't realize. Thank you. Next act is about the Cyber Resilience Act. I hope that everybody has already heard about Cyber Resilience Act. It's basically a new law in Europe that will come into effect starting in probably 2026. That requires everybody who makes a product, between quotes, but a product can also be a service, actually, using a software component has to take care of security. And it specifies what that means. And so this talk gave a bit more detail about, okay, what does it mean? And then impacts on okay, what does it mean when you use Yocto? So this was, for me, the most interesting slide. So it gives a nice overview of what you have to do according to the CRA. So you have to make sure that you do security by design. That, I mean, security is taken into account when you create a product. This also means you need to do risk assessment. So how can it go wrong? How can your product be hacked, or what risks does it get you? And then you have to manage vulnerability. So if there is software that allows a break-in, then you have to be able to identify that. So if you use some existing software in your products and a vulnerability is reported, then you have to be aware of that. Which basically means you need a software bill of materials. They even mention software bill of materials explicitly. And you have to be able to do updates. So if there are vulnerabilities and they pose a risk, then you have to be able to update the products. And this it also says that there has to be a long enough support period, which probably is 3, maybe even 5 years after you stop selling the product. So it's it has quite some impact. And you have to be open about this, so you have to disclose when there is a security incident. No, nothing to add. Any questions or remarks? It was Hugo who attended this talk, but Hugo is not here, so he can't add anything to it.
If I can add something.
Yeah.
It's that, basically, since it's kicking in actually pretty soon, the message is that we should really start to implement this in our processes, basically. So when customers want to develop new products now, they will probably land in 2026 or 2027. So it looks like it's only in 2 years, but actually now when you design a new product, all these points have to be taken into account.
Yeah, good point. Anything else? That was it for the talks. But at Open Source Summit, there is also a exhibition where various vendors, including Mind, have a booth where you can visit and see what they offer and talk to the people. And as an example of this exhibition, I've taken one company called Mecha, which is a hardware and software company located in, I don't think it was India, somewhere in Asia. And they built, they already have 3 boards, including software on it. So this is the handheld device with nice graphics of how it's composed, and it's somewhat hackable. For instance, you can replace the input unit, which is here. You can replace the LCD display with something else. And we're going to order one of these to play with. Or maybe Radovan already ordered it. I think you already ordered it, right, Radovan?
Yeah, I contacted them to be part of the pilot program.
Yeah.
There is also some security, like I think it's a C050, I think, or a TPM. I don't remember correctly, but there is so if people want to hack around that, have test some like secure boot with the device certificate and things like that, I think it's a good board to have fun with, to play with. And we are probably, it's only supported in Yocto, and we are maybe going to add support in Buildroot, maybe.
That's what I would like to do, yes, indeed.
Yes.
That was it for Open Source Summit. Or were there questions about Mecha or the exhibition? So then we can move on to Linux Plumbers Conference, which was the second half of the same week, with actually one day overlapping. The 18th of September was overlapping between the 2 conferences, and Radovan and I attended LPC all 3 days. And LPC is something quite different. So if you look at the sub-conferences, it looks even bigger, but it's actually much smaller because these, they call it microconferences. They really are only half a day. So it's short microconferences. And they are, the intention is also very different. The intention is to have more a place for discussion than a place for dissemination. So the idea is that a person comes with a problem, maybe a proposal, and then you discuss in the group what possible solutions are or how to tackle it. And then ideally you go home with actions or ideas of, okay, this is what we can do to continue. Again, for us as embedded people, not that much interesting. So most of it is completely not relevant for embedded. What I put in italics here is relevant for embedded, but in reality, if you look at what was presented there, it was mostly looking at servers and not at embedded use cases. So the ones in bold, they really are relevant for embedded, even though the complex cameras in real time, for instance, are also quite often looking at server, or not server then, but well, not really embedded use cases. So a somewhat smaller number of talks from there, and I'm going to go a bit quicker on these because there is less content. The talks are also fairly short usually. So this was an idea from two people from TI who noticed that, so you have the Linux firmware project, which is basically a repository for firmware that is needed by devices, so that it can be fetched from one place, that you don't have to look all over the place in some vendor-specific repository, which may go away, but it's always there, and it's nice, simply maintained. Now, the problem is that there's some firmware which is already needed by the bootloader. So before you have the Linux firmware package available, and before you have a file system or anything, examples are the firmware used by the DDR, so the memory controller, by a security enclave, those kind of things. And the same problem as exists for Linux firmware exists here as well. Currently, each vendor has their own repository, and so they want to use put it somewhere central. The best idea would, of course, be to put it in Linux firmware itself. Unfortunately, they didn't seem to be very willing to include the boot firmware. So the idea of Linux firmware is that it's stuff which is also has a known name, a name that is what is used in Linux when the firmware is loaded. So the constraints are a bit different for the boot firmware. So I understand why the Linux firmware people were not too enthusiastic about it. So they want to create a new repository like that, and Denks is actually willing to host it because Denks is already the owner of U-boot, so the boot firmware fits with that. There were some questions from the audience though. So for instance, for the boot firmware, there are often different variants, and often also it's like for the security enclave, the vendor provides a default firmware, but you also have source code that, so you can write your own firmware. So it's not that you have to take that particular blob. So either there are going to be many variants in there, or it's only going to be partially used, or well, it's not so simple. But there was no conclusion about all these things, so it's just questions that were raised. Questions or remarks? This was a really out there talk. So it was about AOSP, so the Android open source project. basically you can build Android from source, but that project is a really weird project. So it's basically a collection of more than 1,000 repositories, which are all, not all, but a large part of them are forks of open source project. Like there's a an OpenSSL in there, probably. There's probably a curl in there. All of these repositories are forked. With then tooling to manage that and to have a build system on top of it. The build system is also crazy complex. So there are actually 4 different build systems that were used historically. And what we end up with now is a Franken build system that combines some of these. And then it actually is not even complete because the toolchain, the kernel, the bootloader, they are not in there. So they are all pre-built binaries that magically appear. And so what Chris wants to say is, it would be nice if AOSP switched to Open Embedded as a build system. But yeah, Google is not going to do that. So I'm not sure what the point is. Questions or remark? This one was from somebody I know very well. It's basically a talk about what was mentioned in an earlier talk in Open Source Summit, that build systems generate license information, but it's actually not enough. And what can we do to improve that situation? And this was, because I did it, of course, it was really a discussion talk. So there was a lot of discussion. Yeah, one interesting thing to know is that Yocto can have different licenses for a binary package, even if it's generated from one recipe, and that is often needed. For instance, that you have a recipe generates a documentation package that is subject to the GNU documentation license, and it also generates a binary package, but there is no documentation in there, so it's just GPL and not the documentation license. There was actually a remark there from Bradley Kuhn that it's not so clear that you can split things based on the license of a source file, because the law doesn't talk about files. It talks about works. So we had all kinds of ideas about working with source files to get more accurate license information, but yeah, I actually think he was full of shit, but it's a valid remark that the law does not talk about files. So other remarks, yeah, what we actually need is the license information about the source files, and then a concluded license of the binaries. But the concluded license, we actually, for all types of licenses, we need a license of the source files. So that is actually the most important thing to be able to convey. We don't really need to conclude a license of the binary itself. We more need to conclude a license about what we send downstream, or a set of licenses. Important remark also is that this may depend on how the package is configured. So especially with vendor dependencies, if that dependency then turns out not to be used due to configuration, then well, that license doesn't apply. But then, yeah, ideally there should be an automated way to verify that what we think is the set of licenses that apply is really correct. So tracking of which sources go into the binary, with again a remark, yeah, file-based is not necessarily correct. And then Thomas Petazzoni came with the idea that we could actually rely on the compiler for this, so that the compiler has already information about which files go into the binary. So yeah, just use that information. Yeah, that was it. Questions or remarks? package managers. So APMs stands for Application Package Managers, and so that's pip, cargo, Go modules, npm, Ruby gems, all those. Every language has their own package manager, basically, which is a problem for build systems, because build system like Yocto and Buildroot wants to make certain of some properties. For instance, that you can do offline builds, that you can first download all the sources and then do the builds offline. Also, that you can make a collection of sources and archive it and know that you can later do a rebuild from those sources. Those APMs, they break those things, basically. So they can pull in dependencies in the middle of the build, which means that that part is not going to be part of the source code collected by the build system. It has effect on patching. The version management is a horror. And there are several ways to deal with those APMs. But the end conclusion is actually nothing we can do. But okay, so what can we as a build system do about it? We can vendor dependencies. So basically, that's what is done in Buildroot. Is that when you build a Rust package, Buildroot starts with downloading all the dependencies. So uses a cargo command to download all the dependencies, archives those all together in a big tarball. And then during the build, that archive is used, and cargo is no longer allowed to fetch anything from the network. Second thing we can do is redo what the APM does, means creating separate recipes or packages for all the dependencies, and do the dependency management ourselves. This is what was traditionally done for Python packages, for instance. And a final thing we can do is say it's not my problem, and just run the APM. And yeah, okay, that breaks your source archive, but if we're not going to solve it. That's the third option, which in Buildroot, for instance, we use for npm, because npm is hopeless. So discussion resulted in no conclusion, as in no real solutions. The only interesting thing about the discussion was that the underlying issue is that developers don't care about backward compatibility, which requires this vendoring or this APM type of dependency management, where you log specific versions and so on. In the old C world, you had releases of a package, and then another package uses that, but the dependency management was much more easy, because you have you can rely on the provider to be stable. There was also some doubt whether this statement was true, because yeah, in Rust world, for instance, it's not. And in Go actually as well, it generally is backward compatibility is kind of provided. Questions or remarks? Did I attend this talk? I forgot it. Yeah, I attended this talk. So real-time safety, yes. So we have a real-time kernel since a couple of weeks. Now, unfortunately, having a preempt RT kernel doesn't mean that the application is actually real-time safe. There can still be your application can still break things, which basically means it can still have unpredictable latency. Basically, this happens whenever the application calls a function with unpredictable latency, and that happens when the application does a syscall that can block on something non-RT. That can be, for instance, reading from a pipe, and then the input of that pipe is provided by a non-real-time process. or a process with lower priority. Or it can be calling something like printf, because printf goes through some console, which is some hardware device with logs and with unpredictable buffering. Yeah, you can block on that. Xenomai in the olden days had the concept of a co-kernel, and with that concept you could actually detect whenever an application was doing a callback into the Linux kernel. So an application can do that, but it is automatically detected because Xenomai has to schedule the Linux kernel at that point. Xenomai had some tools to be able to debug that. So the first problem that you need to solve is how detect this in a situation where you don't have a co-kernel. It's still doable because you can mark things as not something real time, like console driver, but it's much more complicated. And then the second thing is that, yeah, you only want to do this kind of thing for the real-time application, so you somehow have to say that the application is real-time. I guess that's basically when the application has a real-time priority, but okay. And then finally, you have to tell the application, yeah, you violated this constraint. It has to be decided how. Unfortunately, there was no discussion and no conclusions because these were actually interesting questions, but no feedback to Jan. So we didn't really get anywhere there. Questions or remarks? And now I give the floor to Radwan.
Yeah.
For some talks that I did not attend.
So I also attended the Rust microconference, actually because I mean, at my current customer, we are slowly moving to Rust, moving away from C++ actually to Rust. So yeah. So I went to two different conferences. One was Introduction to Rust Quality of Life. So yeah, I've put it here. Actually, I would not recommend to directly go seeing this conference if you have no clue about Rust, because and yeah, basically every time you see an introduction to Rust, the first thing they say is you actually need to code to learn a language. So that's but yeah, but you can still go watch it. But I think before watching this conference, it's maybe better to go read the Rust book. The second conference was a bit more interesting because it was a developer, a C kernel developer going through the learning curve of Rust. So learning Rust while writing a Rust driver. In this case, it was for Nouveau. So it was pretty complex. So he basically discussed all the hassle he had to go through. And it was also a big discussion about processes that are now in place, how they are going to like manage batch reviews, like because some of the maintainers have no clue about Rust, so how they are going to review Rust patches and things like that. So it was really, really interesting talk. Not really on the technical side, but more on the it's a journal. So basically, the person was explaining everything he did to achieve writing his first driver and learning Rust. So I think this is really interesting. The next, the third talk I wanted to talk about is testing. So this was a really, really interesting talk. It was a university given by a researcher actually who went through measuring and understanding Linux kernel tests. So we went through all the test suite that exists and like measured coverage. So it's, and the main takeaway is that the coverage is pretty low and actually pretty unacceptable for like serious project. And so the guy presented a tool that helps going through the tests and really easily improve coverage. So basically the tool they developed allow you to very quickly identify which test is covering which part of the kernel code, and gives you the line where you can add a condition basically to extend the coverage. So it's a really, really useful tool. So I think you should really at least go watch the demo. The video is over there, so it's a really interesting talk. I remember at some point we had to like verify the quality of a kernel, and you are always like, yeah, we got this kernel from NXP. How do we perform tests? What is available? What is the coverage? So that was a lot of questions that came from the testing team, and I think this talk is pretty interesting. So it's a bit also out of what we usually do as embedded software. But yeah, testing is also an important part. So yeah, at least go check the video, the demo. It's a nice tool. I don't think it's already available. It's there. The patches, part of the patches are, but it's not merged yet, I think. Any questions, or you want to add anything to?
Okay, thank you, everyone. That concludes our overview of these talks. And as I mentioned in the beginning, there's an option of looking at videos of one or more of these and discuss the contents in a full tech talk session. And so I've made a form where you can select which talks you think are interesting. Only fill it in if you think something is interesting. Of course, otherwise don't bother giving me an empty form. And if there is sufficient interest, then we will organize a tech talk where we watch one of these videos. I will send this by mail, so you don't have to copy the link now by hand. Okay, then thank you everyone for your for attending this session. The next session will be in 2 weeks on Tuesday, and will be Radwan about remind me of
MicroPython. So that's
MicroPython. Yeah,
MicroPython. So Python in the context of microcontrollers.
Okay. Thank you, everybody, and goodbye.
Thank you, Arnout and Radwan.
Thank you. Bye.
Bye.
Thank you. Bye-bye.